I get it, UVE got a tight budget for your lab. You've seen a bunch of shakers online, and you're not sure if dropping a few $100 on the IKA HS260 will actually move the needle for your work. You've probably spent an evening scrolling through specs, wondering whether the extra cost over a basic orbital shaker is really justified, or if you'll end up with a piece of equipment that just sits idle because it doesn't fit your workflow. Link is in the description if you want to check the product details on Amazon. So let's walk through exactly what this machine brings to the bench, who will actually benefit from it, and where it might fall short, so you can avoid that buyer's remorse before you hit Add to Cart. First off, the HS260 is not just a shaker you set on a bench and forget about. It's built around an electronic time-switching clock that lets you program up and down cycles without having to be there the whole time. In a real-world scenario, imagine you're running a series of enzymatic reactions that need precise incubation periods, some 30 minutes, others 2 hours, with different shaking speeds in between. You can dial those intervals into the digital display, start the run, and walk away knowing the machine will automatically switch speeds and shut off when the timer hits 0. That level of automation is what separates a lab-grade shaker from a hobby-grade mixer, and it's the kind of thing that actually saves you hands-on time when you're juggling multiple protocols. The integrated endpoint positioning is another feature that sounds fancy, but becomes useful when you're pairing the shaker with a robotic sampling system. If your lab already uses an automated pipetting robot, the positioning point gives the robot a reliable reference to pause at the exact moment the shaking cycle ends. That means you can have a closed-loop workflow where the robot extracts a sample the second the agitation stops, preserving reaction conditions that would otherwise drift if you had to manually intervene. For a small academic lab that's still using manual pipettes, this might feel like overkill, but in a high-throughput setting it can shave minutes off each plate and reduce variability. Now, who should actually consider buying this unit? If you're running a research group that routinely needs precise timing and speed changes, think cell culture centrifugation alternatives, protein crystallization screens, or kinetic assays that require exact shaking profiles, this shaker will fit right into your routine. The ability to program multiple speed steps means you can, for instance, start a gentle rocking phase to keep cells in suspension, then ramp up to a vigorous shake to break up aggregates, all without touching the machine. That flexibility translates into real experimental reproducibility, which is the currency of any good lab. On the other hand, if your work is limited to simple, single-speed mixing, say you just need to keep a buffer solution homogeneous for a few hours, the HS260 might be more than you need. A basic orbital shaker that runs at a fixed speed will handle that just fine, and you'll save a chunk of cash that could be redirected toward consumables or a better microscope. Also, if your bench space is cramped, the dimensions of the HS260, while not massive, do require a dedicated spot because the unit's base and the digital control panel need room for the cable and the optional positioning probe. You'll want to measure your bench before you order, otherwise you risk a cramped setup that forces you to shuffle other equipment around. Talking about daily usability, the digital display is clear enough that you can glance at it and see the current speed, remaining time, and which step you're on. The interface isn't a touch screen, so you won't accidentally change a setting with a stray finger, but the buttons are tactile and give a satisfying click. In my own experience with a similar IKA model, I found that the clock's accuracy stays within a few seconds over a full 8-hour run, which is more than adequate for most protocols that don't demand millisecond precision. The speed range is wide enough to cover low rocking to high orbital shaking, so you won't feel limited when you switch from a gentle cell culture agitation to a vigorous nanoparticle dispersion. There are a couple of practical trade-offs you should be aware of. The integrated positioning point requires you to attach a small probe to the shaker's platform, which adds a step in the initial setup. It's not a complicated process, but if you're new to the system, you'll need to spend a few minutes calibrating it to make sure the robot reads the right position. Once it's set, it stays put, but anytime you swap out the platform for a different plate size, you'll have to readjust. Also, the unit draws a decent amount of power, roughly 200 watts at maximum speed, so make sure the outlet you plug it into can handle the load alongside other equipment. In a shared lab with multiple high-power devices, you might need a dedicated circuit to avoid tripping breakers. One hidden strength that's easy to